Hello, today we're going to be taking a look at simplifying and factorizing some of the simple algebraic expressions and equations. Hopefully you find it useful. So let's start with question number 1. Here we just have to do a simple expansion. We just have to multiply -3 by, let me just change that marker real quick. So we've got -3 times w squared, and then it gets multiplied by -z. So we're going to get -3w squared plus 3z, and that gets added to the 3z next to it, minus 5w squared, and then again the 8 also gets sort of expanded, so we get minus 8z plus 16, sorry, minus 16, because it's got a minus, right? So minus 16. Now, we're going to add the like term. So the first thing that I did, all right, again, I'm going to write my steps. I expanded. That's my first step. The second step, I have to add the like terms. So I have to add the like terms and simplify, and then I'll be done. So I'm going to add the like terms here. So -3w squared minus 5w squared, they get added. They give me minus 8 minus 8w squared. And then I have 3z and 3z, so they add up. Actually, they give me 6z. And then I have negative 8z, so I have to subtract the 8z here. I forgot about that. Minus 16. So I'm going to get 8z minus, minus 8z plus 6z is going to give me minus 2z. So I'm going to get minus 8w squared minus 2z minus 16. This is particularly useful for some of the SAT conversions and sort of SAT math simple parts. Let's take a look at the second one now. We got 3 times 8a squared minus b squared. So 3 times 8 squared, what is that? 3 times 8 is actually going to give us 24. So 24a squared minus 3b squared minus 24a squared minus, again, we have minus 3 times minus b squared. So that's going to give us positive 3b squared. Keep in mind, minus times minus gives us a positive number. So the 24s cancel out, thankfully, and the 3s also cancel out, it turns out. So we are left with nothing. Let me just double check. All right, and yep, that's it. So they cancel out. Let's take a look at the second one. Do the following operation, combine the like terms and simplify the following expression. So this is actually kind of giving us a hint on how to solve them. So again, we just have to expand these. We just have to do 2a times 2a, 2a times -3, and then 3 times 2a, 3 times -3. So 2a times 2a is going to give us 4a squared. 3 times 2a is going to give us 6a. And then we multiply 3 by 2a again. So that's going to give us plus 6a minus 9. So we're going to be left with 4a squared plus 12a minus 9. There you go. Let's take a look at the second one, b. It says ax plus b plus 1. All right, so we're going to have to multiply ax by 2a, ax by minus bx, and then ax by -1. So we're going to get 2a squared x minus abx squared minus ax, all right? And then we're going to have to do the same thing for the second term. So b times 2a, b times bx, and b times -1. This is going to be quite a long one, but it's going to be easy, actually, once you get the hang of it. Plus 2ab, because b times 2a is 2ab, minus b squared x, and then minus b. And let's do the last one. 1 gets multiplied by 2a, so that's going to be positive 2a minus bx, and then 1 times -1 is just -1. So do we have any like terms here? Do we have anything that we can add? Apparently, we do not. So that's the answer for this question, all right? Nothing else left. Is there anything that is like? Nope, there's no like terms here, so we can just skip it. Right, let's move on to the third one now. Here it says use algebraic identities to expand the followings. Well, what are algebraic identities? We have a couple of them. We know that we have a squared minus b squared, right? And that's going to be like a minus b times a plus b. And then we have a squared plus, we have a plus b to the power of 2. That's the sum of 2 squares. So basically sum of 2 numbers to the power of 2. That's going to give us a squared plus 2ab plus b squared. The first one is a difference of 2 perfect squares. And last but not least, a minus b to the power of 2. That's going to give us a squared minus 2ab plus b squared. Now, let's take a look at question number A. Which one represents one of these 3 rules in the most similar way? Number 1, 2, or 3? Well, obviously it's number 3, because it's as if this whole complex is a, and then this one is also b, and it's a minus b squared, right? So we can say that a squared, that's going to be 2x squared let me just write that down, 2x squared minus 2 times a, which is 2 times 2x, times b, which is times 3, plus b squared, which is plus 3, negative 3 squared. So we're going to get 4x squared minus 2 times 2 is 4. 4 times 3 is 12. So 12x plus 9, because negative 3 is in the brackets. Now for b, it's going to be the second rule. So it's going to be a squared plus 2ab plus b squared. And keep in mind, 3x, this whole lot is a, and this whole lot is b. So we're going to be getting 3x squared. You're going to have to substitute the letter a inside of this formula, this one here. So 3x squared plus 2 times a, which is 2 times 3x, times b, which is 2, plus 2 squared. And that's going to leave us with 9x squared plus 6x. 6 times 2 is 12x plus 4. End of story. And last but not least, this one, you can try this one on your own. You can pause the video now and try doing it. All right, so this one is actually the difference of two perfect squares. So we have a squared minus b squared, right? And they give us what? They give us actually a minus b and a plus b. But in order to understand why you get to that formula, I'm going to actually do this manually. So 2x times 2x, that's going to give us 4x squared, right? And then 2x times positive 3, that's going to give us positive 6x. And then negative 3 times 2x is actually minus 6x. And then minus 3 times 3 is actually positive 9. So you see the 6x's cancel out, and you just get 4x squared plus 9, which is what you would have gotten if you had used this formula. Because you know this is a and this is b, right? So you could have written it from the beginning as 2x to the power of 2 minus 3 to the power of 2. And that would have left you with, sorry, this is going to be minus 9. I wrote positive 9 there, that's minus 9. So the answer here is minus 9. That would have left you with, anyways, back to here, with 4x squared minus 9, which is exactly what you would have gotten if you had done it manually. But here we're using an algebraic identity for it. All right, so here we have some examples of factorization. I'm going to start with the first one, which is a factorization of simple like terms. Now, before you do these, you obviously have to have a background in how these work, because factorization, simplifying all these things, they require you to have a good level of algebra, but hopefully you're practicing that and getting better by it. Number one, it says 2 a.m. Okay, so let's see if there's any like terms in the first one. Obviously, the first like term we see there is 2nm. So we can factorize out of 2m, we're going to get a minus b. And then for the second part, we can factorize out of y. So we can factorize out of minus y, and we're going to get positive a minus b. And there you go. You can actually now sort of, disregard these two and just write it as 2m minus y times a minus b. All right, for the second one, it's the difference of two perfect squares again. So here what you have to do is you have to write it as 2x to the power of 2 minus 6x. Actually, let's see if there's anything. Okay, no, that doesn't work here. So let's try something else. Why don't we factor out of 4x? If you factorize out of 4x, we're going to get x minus 3, right? And that's it. That's factorized. Let's take a look at this one. This one looks like it could be a difference of two perfect squares. Let's find out. So we can write that as, what raised to the power of 2 gives us 16? 4, and then obviously just 4x to the power of 2. And then what raised to the power of 2 gives us 81? How about we go with 9, right? There you go. That's the difference of two perfect squares. So the answer is 4x minus 9 and then 4x plus 9 according to the identity. And I don't have to do any further explanation. Hopefully you understand, because a squared minus b squared is just a minus b times a plus b. All right, now the last one is a combination of some of the factorizations that we've seen. We can just factorize out of the first common factor right away, which is 2. So we can factorize out of 2. We're going to get x squared minus 4x, because that's minus 8x, so minus 4x plus 3. All right, so we can just leave the 2. We can just kind of disregard the 2. And we can write 2 times. Well, let's factorize on the inside now. We're going to open up 2 brackets, and we're going to do the old method of what multiplies to negative 4, but adds up to 3. Okay, so what two numbers are in your mind that multiply to negative 4, but add up to positive 3? Okay, so we have to write x here. Well, what if we use positive 4 and negative 1? 4 times negative 1 gives us negative 4, and then 4 plus negative 1 gives us negative 3. That works. So just x plus 4, x minus 1, and that's it. That's the answer to this question. So, again, make sure you do a lot of practice on these. You can check out our channel. We have lots of practice papers there. You can actually search it up online. You can just say, free practice papers for factorizations, and then you can kind of further develop your skill in these. If you're still watching, thank you for your support. Make sure you subscribe and share the video. Take care, and